This is Michael King. In this video, we're going to talk about how to calculate expected portfolio return and risk. In Booth, Cleaver, and Ricada, this is sections 8.4, expected return and risk for portfolios. So we have two concepts here. One is the idea of a portfolio, and the second is modern portfolio theory. A portfolio, as the name suggests, is simply a collection of securities, which could be stocks, bonds, that are treated as a single asset. Modern portfolio theory is the theory in finance of how to invest by combining securities into portfolios that optimizes the risk-return trade-off through diversification. Modern portfolio theory is typically associated with Professor Harry Markowitz, shown here, who shared the 1990 Nobel Prize in Economics with William Sharpe and Merton Miller. Together, they changed the way that we invest, and you can see an interview with Professor Markowitz at this website. So let's start with the expected return for a portfolio. We've already seen how to calculate the expected return for individual stocks. You can see the formula here is quite similar. It's simply the weights of different stocks or securities times their expected returns and added up. Notice that the weights have to equal to 1. So quite straightforward. So let's start by looking at the securities that we're going to combine in this portfolio, security A and security B. We need to calculate what their expected returns are across different states or scenarios. And here we have 4 scenarios: high growth, moderate growth, no growth, and recession. Notice that stock A is going to be up 60% in the high growth scenario and down 25% in the recession. Stock B is going to be up 5% in the high growth scenario, 0 in the recession, and actually is going to outperform in the moderate growth scenario. So using the formulas above, we can calculate the expected returns and the expected standard deviations, which are our measures of risk. Notice that the expected standard deviation for stock A is quite a bit larger than for stock B. So using the weights for stock A and stock B in a portfolio and these expected returns, we can calculate the expected portfolio return. So let's assume that we invest $600 in stock A, $1,400 in stock B. What would be the expected portfolio return? Okay, it's simply take the portfolio weights and convert them into percent. We see that for a portfolio of $2,000, 30% is going to be in stock A, 70% in stock B. We have their expected returns from the previous calculation, and it's simply a question of multiplying the weights times the expected return. So 30 times 10 and 70 times 8. Adding them up, we get that the portfolio expected return is 8.6. Again, it makes sense. It's between 8 and 10%. What would happen if you invested $2,000 in stock B, which is all of your money? What would be the expected portfolio return? It would be the same as the expected return for stock B because it is not a portfolio. It is simply one stock. How do we calculate the expected portfolio risk? Well, we're going to use, again, standard deviation. And it's going to follow this formula here where you can see that it's weight squared times standard deviation squared for each of the stocks, plus a third term, twice weight A, weight B, and the covariance of AB. So what is covariance? It's a statistical measure of the degree to which the returns of two stocks are correlated or fluctuate together. It can be calculated using this formula. Now notice that we're going to be looking at forward expected returns, and so we have to look at how those expected returns are going to move or co-vary with each other. So it's going to be the probability of a state times the actual return minus the expected return for stock A times the actual return minus the expected return for stock B across different states, summing it up. Let's take a look. So here we have, again, our stock A and stock B with our expected returns and our expected standard deviations. Using this covariance formula, in the high growth scenario, the difference between the state return of 60% and the expected return of 10% is 50 for stock A, and it's -3 for stock B, which is 5% minus 8%. Okay. We do the same for moderate growth, no growth, and recession. We calculate them for each of those scenarios. In the final column of the table, we're going to be taking the product. So it's the probability times the difference for A and the difference for B. We take those products and we sum them up over the 4 states, and that gives us the covariance. And you see the covariance is 75. Now, what does that 75 mean? It's quite hard to interpret because that is actually a percent squared, which is something that we can't really get our head around. So in a moment, we're going to talk about something simpler called the correlation coefficient. But let's just continue using covariance. Harry Markowitz showed that you can calculate the expected portfolio risk using this formula where it's the function of the weights, the standard deviations, and the covariance. Okay, so if we have the 600 invested in stock A, 1400 in stock B, what's the expected or ex-ante portfolio risk? Okay, so we just have to take the weights, the standard deviations, the covariance. We square the weights, we square the standard deviations, and we multiply the squared weight times the squared standard deviation for each stock. We get the final term, which is twice the weight A, weight B times covariance. And we sum them up and take the square root. And we see that the expected portfolio standard deviation is 10.7%. Does that make sense? Well, the expected standard deviation of stock A is quite high at 22.7%, and the expected standard deviation for stock B is much lower at 8.7%. The portfolio standard deviation is between those 2 points, but closer to stock B, which is actually making up 70% of the weight. So yes, it does make sense. So if you don't understand what covariance is, you can also use correlation. And correlation is simply a way to normalize the covariance by dividing by the 2 standard deviations multiplied by each other, which is a squared percent. Okay, so we're going to have squared percent in the top and squared percent in the bottom of this ratio. Rho is the Greek letter that we use for correlation. The correlation will always fall in a range from a low of -1 to a high of +1. +1 would imply perfect positive relationship, where the 2 stocks always move in the same direction. Correlation of 0 means that the stocks do not show any relationship. They move randomly relative to each other. And a correlation of -1 would be a perfect negative relationship, where they always move in the opposite direction. Okay. Notice that correlation doesn't have anything to do with the magnitude of the movements, only the direction of the movements. So let's take a look at a couple of series. So this top graph, we're going to see positive correlation. You see that the red line, when it goes down, the gray line moves down. When the red line goes up, the gray line goes up. These two are positively correlated. Negative correlation is when they move in opposite directions. You can see that the gray line moves down and the red line moves up. And when the gray line moves up, the red line moves down. Now notice that the magnitudes do not matter. It's the direction that matters. Does correlation equal causation? This is a question that many people get confused about because they think, well, if two things are correlated, one must be causing the other. No, correlation does not imply causation, which means one thing causes the other. Let's just take a look at an example. Here's one where you look at the divorce rate in Maine, USA, versus the consumption of margarine in that state. As you can see, they seem to be highly correlated, and you may be tempted to assume that if you consume more margarine, that you are more likely to get divorced, or divorces lead people to consume more margarine. Even though the correlation here is very high at 99.26%, it is not causation. To calculate the portfolio standard deviation, you can now use the correlation coefficient. Here you can see that we've substituted for covariance AB, we've substituted standard deviation A times standard deviation B times the correlation coefficient rho. So again, you can see that in the table, you have the weights, expected standard deviation, you calculate the covariance. You can calculate the correlation coefficient, the correlation of 0.379, which is positive, but is below 1. Subbing this into this formula above, we get the same expected standard deviation for the portfolio of 10.7%.